Well, it's kind of interesting working in cybersecurity. Just curious, how many of you guys work in security in particular? Well, a few, actually, basically 50%. If we were to hold a summit like this 10 years ago, there would have been like 3-4 hands. This is really growing industry, so I think it's kind of interesting. Actually, thinking back, like 15 years when I started doing this, or maybe even 20. I'm trying to withdraw some years. It was kind of interesting. I was standing on a stage at Barnes with some eminent people working in the IT infrastructure in Sweden. And I was saying, everything is vulnerable. You can break into basically everything. And they said, well, no, that's not true. If that's really the case, why hasn't it happened already? And I said, the evilness hasn't matured yet. And I think what's happening right now, it is maturing. The cyber threat is really becoming a reality. So that's something we're going to talk a little bit about today. And if you never met me before, I'm running the security team in TrueSec. And we do a lot of different things, but two things we focus a lot on is breaking into IT environments. We've done more than 1,000 penetration tests over the last couple of years. So we have a really great insight into how to really break into an environment. Another thing that we do more and more, in relation to what I said a few minutes ago, is that we do real investigations. We investigate cyber intrusions. And that is really picking up. It's becoming a good business. Think about that for a while. You were supposed to laugh, but it's a good thing you're not, so it's fine. So, one thing that I think is important is to talk about the real things, the things that really matters, the things that's happening in the real world. And it's interesting looking at this big trial that is in Malmö right now. I think most of you guys have heard about it. But these are a team of 8 people. They've been breaking into approximately 600 or 700 Swedish organizations and companies. And what's interesting is that they have been extremely successful. There are 8 guys. The guy that is accused of being the main man is younger than me. He's 38 years old. And he's been so successful in doing this, it's really scary. Especially when you think in terms of the methodology he's been using. Because in basically every case, they have got into the environment by just sending an email with an email attachment. And you may debate whether or not that should be possible. They send an attachment, someone clicks on it, and then you break into that environment. Or at least that computer, which is the initiation of the big attack. When we do our red team exercises, when we break into an environment at work, we have a 75% hit rate of making one individual click on an attachment and execute macro code. Statistics says it's somewhere between 11 and 13%. But when you tailor it, you have a 75% chance of executing code on someone's workstation. Think about that for a while. That's why this has been so successful. Another interesting thing is that he used tools that are free to use, that you don't have to pay for. So he didn't use these sophisticated NSA or CIA tools. He was just using stuff he downloaded off the internet. This is PowerShell Empire. You run it in Linux, but then you target Windows workstations. What's interesting about this is it runs PowerShell, so it doesn't end up on the file system. It runs in RAM. It makes the target execute PowerShell code. So it basically sent them a macro and made them double-click, open the macro, run the code. That's all it was. You think about this guy. This is the guy who is accused of being the brain, the mastermind behind this attack. His name is Christoph. It's open public information. You can just follow the trial. He has admitted to some of the stuff, so normally you would not say until he's sentenced that he did it, but he said himself he did it, so I guess he did some of the stuff. He doesn't claim to be the mastermind, though. I wouldn't either if I were him, so who knows? Maybe he wasn't. But this is his GitHub repository. So it's so interesting. You can actually read what tools he was forking so that you find out exactly what he was using. This is not really a difficult investigation in terms of understanding what he was using. There's a number of different tools he was forking over time. This is just the current. If you go to today, this is what it looks like right now when he's in custody. But it used to be more complex. But what you should think about is 8 guys can come together. They can download free tools off the internet. They can start educating themselves. And that's all it takes to break into 600-700 companies before you get caught. You learn some things. I read the entire investigation. I mean, I could talk about this for ages. I only have 15 minutes for this entire presentation. But it's interesting when you see that, for example, they logged on to some of the target's cloud services. So they were installing malware on the workstations, finding out the logons for their cloud services, and then they moved into the cloud. That really links the dependency between the workstation and the cloud services. So in the future, when we move more and more into the cloud, I guess we're going to really have to protect the workstations interacting with the cloud. That's going to be a major thing to think about. This is not one of the typical things. They were mainly after money. Some people say they stole about 250 million Swedish kronor, which translates into a little bit more than 25 million euros. They're only on trial for basically 50 millions. But it's funny, they did some other interesting things as well. While he had this power, when he realized I can basically send an email to anyone and run code on their computer, they even attacked law firms, lawyers, individual laptops, in order to start monitoring and see what they know about a certain trial. So that's when we really start to affect the justice system as well. So you learn a lot of interesting things from this. Another thing when you read the investigation is you can see how the police interact with the target organizations, and they ask them questions and they answer. In many of the cases, they were asked, do you have logs from the time around the intrusion? And many of these organizations doesn't even have firewall logs from those dates, because they don't save logs. They can't really do an investigation on their own. There is no evidence. It's like you have a big store and you have videotaping and you don't save the tapes at all. And this is reality, it's non-disputable. This is what you can read from the real questions. So this also exposes the targets. Their weaknesses is really getting exposed here. And it makes you think, if these guys got caught, they broke into 600-700 organizations. You start to think about statistics. And this is US statistics, but it's kind of interesting. If you want to do an armed robbery in the US, the chance of getting caught is 1 in 5. I mean, it is a fairly bad business case, don't you think? Do you think anything? How many of you guys would be ready to do it? 1 in 5. Good job. I would be interested if someone raised their hands. We would have had a problem. I would have called someone. So, okay, 1 in 5. Can you think for a while, what do you think the statistics are on getting sentenced or convicted of an identity theft campaign? What do you think? 1 in 500. Can you do better? 1 in a million. Well, let's take it somewhere in between. It's 1 chance in 50,000 that you get caught. Can you realize the business case? It's 1 in 50,000. That is the industry that is being created today in cybercrime. Today you don't get caught. This is some threat actor sophistication mapping. I don't want to go through this. I just want to tell you that This was like a hacker, criminal, something. He was on this capacity. If you have your own organization, you should think about all these different threat actor categories and think in terms of which ones could be in relation to you or could be relevant to you. And then you think if one team can do 600-700 intrusions and most of them don't get caught, think about the risk. Do some math. We're in a new world. I'm going to run through the rest of this, but just to give you some insights, Equifax got caught. 44% of all the US citizens' social security numbers and other data is in that database. I don't think those guys are going to get caught, but they were missing a patch. The Apache struts. Deloitte. They lost emails from 240,000 staff members. They have a lot of financial data and other things in their emails, for sure. And they were compromised because they lost an administrator account. One security firm called Holden Security, they were checking some sites. I don't know if that's actually legal, but it wasn't us who did it. They found a site in Argentina used by Deloitte, the employee web portal over there. They could log on with admin. So you don't even want to know what the password was on the big site. Another interesting thing is ransomware. I'm not going to go into ransomware details, but I have asked every customer I met this year, did you have any experience in being targeted by ransomware? I'm not asking you, my friend. I said I have asked every one of my customers. Maybe you're my customer, but what's interesting, what's interesting is that everyone said yes, if I asked the question correctly. If I said, do you have any workstation that got targeted, that executed code? So everyone, from my experience, or the ones I asked this year, have been targeted. And what's interesting is that targeted attacks are still more common, all in all, than ransomware. So statistically, if you had one ransomware attack, you should have at least one targeted attack as well. But that one is not visible. The ransomware attack is made to see. The other one is made to hide. Interesting statistics in the US, 70% of all the targeted organizations pay ransom. That's why some of the ransomware campaign has accumulated 235 million euros. So they're becoming billionaires in Swedish money. Swedish Transport Agency, I want to talk a little bit about trust. I have some seconds left. You need to think about who to trust. We trusted IBM to run stuff in the Czech Republic that was basically used by Serbian ex-military intelligence agency people. That's bad. But it's kind of interesting. I'm not saying anything in particular about Kaspersky. I'm just saying that the US government are not using Kaspersky anymore after they basically found out that a member of the NSA TAU team, a penetration testing team, put the TAU tools on his computer at home. And that computer was exfiltrated, so they stole all the hacking tools of the TAU team. And they suspect that the Kaspersky antivirus was the source of extraction. It is a Russian antivirus, so now you can't use Kaspersky anymore in the US government. Think about this in terms of who to trust. Especially in this world of cloud. Who do I trust? So make sure that you pick partners and cloud vendors that you can trust. And also make sure that you can trust them, assess them. That's what got wrong in the transport agency. Nation-state tools. When you lose information, you learn about stuff. It's interesting, this is a secret manual of some nation-state tools in the CIA. One of the things I think is most important is that they create their own file system on disk. So they hide their tools outside your file system. This is an old tool. All I'm trying to teach you is that we need to think about some new things in terms of cybersecurity. We need to realize and assume breach. We need to understand that we're going to get breached. So you can't just protect anymore. You need to identify your assets and your risks. You need to make sure you have the right protection, like in the Struts case, you can't have unpatched software. You need to start detecting. You need to assume breach and realize that we need detection capabilities so that we will understand when something hits us. You need someone to call or something to do when you get hit, and you need to be able to recover. So with those words said, I think it's time to really start the day and start talking about a real stream of how cyber threat actors break into environments and how to protect ourselves. Thank you.
Breaching the perimeter.
Yes. So my name is Kenneth Ljungqvist. I'm a penetration tester and red teamer at TrueSec. Today we're going to talk about breaching the perimeter. So we're going to focus on how to get the foothold inside the environment. Yeah, this is my colleague.
Davide Girardi, penetration tester, red team member, geek, whatever. Yeah, first, when you're doing an attack, which is a process, and we are going to discuss that in a moment, you have to find where to start with. And you have first to get an idea about what you're going to attack, what's your target look like, what's their business look like, and then plan something and start with a technical part. And the technical part is going into the network and begin with something. Today, we are going to discuss a little bit of theory at the beginning and in the middle, just to get an idea about what we are talking about. But everything will be pretty live. Our stuff is based on real-world scenario. You're going to see stuff that maybe you're probably have seen on your own website or your own applications. Don't worry, this stuff is already been reported and patched. So this is not going to be a problem. And we are going to see how we, the evil people, think and how they plan their actions to try to evade detection and convince systems or people to do what we want to do.
Exactly. So the attack path and methodology when targeting an organization, whether if it's a red team assignment or if you're a black hat trying to hack the organization for profits. So what you need to get into the mind of the attacker. Where do you start? Like, you don't know much about this organization. You try to gather as much data as possible. What services do they expose? What people work there? What kind of technologies do they use? And you collect all this data and you turn it into intelligence, and then you act on that intelligence. So that's an example of how you craft a spear-phishing email. You need to know your target to be able to craft an efficient spear-phishing attack, for example.
Yeah, and that's applied to everything. You can use this knowledge to target systems. You can use this knowledge to find a way to enter a building physically, because if you say, yeah, I'm a friend of this guy, and this guy is a very known person there, then it's going to be easier. And that applies also to technical stuff. In fact, today we are going to see, in the very first presentation, we are going to focus on those two things. There are many ways to get into a network. And today we are going to look at exploiting publicly available systems, like a web application or a mobile API, and how to exploit the trust of the users to get an initial foothold. Our goal is to reach the internal systems. And to do that, we have to find a way through one of these four guys. But yeah, we're going to focus on the first two. To do that, we're going to do something live, and we're going to see how it works. We'll start with our target is our corporation. They deal with medical things. They have the usual stuff on their website, information about facilities, reviews, prices, and so on. They have a work with us page where we can see that they're looking for different kind of people, including IT sec guys. And here we can see that, yeah, basically you can contact them, upload your CV on this members area that we're going to look in a moment, and try to get a job. It's pretty common. So let's take a look at this. We are going to, first of all, we can either log in or register an account. We don't have an account, so we are going to register that. I don't want to disclose my private information, so I'm going to use another name. And
so this is just one example out of plenty how to what we find and what we see in the real world. This is a web application. It's a normal case. Most organizations expose at least one web application. If you have, depending on what that web application do, you might be able to upload files. It might just be static pages, and this is the kind of information that you need to gather in the first step of the attack, so you know where to look, and then the experience comes in where you can pick the paths where you know you usually find something.
Yeah, and most of the time it's not just a single thing, point and shoot, especially with technical stuff, because nowadays more and more companies are starting to get some awareness about threats and so on, so maybe there's a vulnerability management in place. They are running scanners and tools. So what we do is find the small things and maybe chain them together to get to something else, something more useful from our point of view.
Exactly.
And so let's explore this area. One thing to notice is that we can upload our CV down here, and then we can contact this guy, Leon Vargo. We have his email down there. And like a very common website, we can upload our profile picture. And here it is. Let's upload it. We have the picture there. And that's me. It's really me. And what someone sees in this situation, when you think as an attacker, the very thing you start to think about whenever you see something is, can I use it for something else? So when you see any kind of file upload functionality, like this example, you think, yeah, sure, I can upload pictures, maybe I can upload something else, maybe I can upload, I don't know, a virus and then host it there and spam it through the internet, so I'm gonna use their systems to do my bad things, or whatever. So to understand this, we are gonna create a text file and see what happens. Let me upload it. Okay, we don't see an image, but if I right-click and copy the image, location, take a look. Okay, I uploaded a TXT file. Nothing so interesting about this. Still, I understand that it's possible to upload other stuff that they don't validate what I'm uploading, or at least they allow files that are text files. So the next thing I'm going to do, this is a PHP-based web application, so I'm going to try to upload a malicious script that I can control. We're going to start with something very simple, like something like this. Can you, I'm basically going to do a PHP info.
This is basically what we're trying to show here is how both the bad guys and we work during assignments where you try to assume stuff, you enumerate it, you look for functions that are of interest. Obviously, a file upload where you can put files on the server is going to be very interesting from an attacker perspective. And then you try different stuff. So you might start off with just uploading a regular image, and then you move on to a text file, and then you build it from there, and you see what happens and how the application reacts to this. And you try to imagine in your head what kind of checks are they doing in the code that we want to circumvent to do bad stuff. So there might be sanitation there, but we might be able to circumvent it with certain characters, or we have to test and see what happens.
Here in this case, when I try to open the PHP info file, I see nothing. It could be that the file is empty. Or, like in this case, the file is there. My code got to the server, but it's not going to be executed. There's a hardening measure. They don't trust stuff uploaded by the users, so I cannot run the code that I uploaded there. This is a good thing. Still, my code is there, so let's try to dig a little bit more. Another functionality which is here is a file manager, where we can create files with whatever content. Or we can add folders. Let me see if I can add a folder with like this name. CloudFront is not cooperating today.
Yeah, so like we saw here, we tried to upload a PHP file, but it didn't execute because they don't allow execution of PHP files in that folder or whatever security mechanism they have in place that stopped us from moving on that path. So we have to take a step back, and we need to check the other functionalities on the site, and if we can maybe chain these vulnerabilities, or because we can upload files on the server, can we use them somewhere else? And that's basically how you need to think as an attacker, and try to find that crack that's going to give you the foothold inside the environment, basically.
So in this case, I'm going to just try to reuse what we did before and upload a PHP file. But it's not going to work because it's not allowed. What we usually do in this situation is try to find which kind of filtering they're running. Is it just on the browser? Maybe there's a JavaScript checking for the file extension, so we can manually send it over to the server and bypass the restriction, or maybe something like that on the server side, like they're checking the content type, so we can change it and send whatever we want, something like that. In this situation, no, it was pretty well implemented with no bypassable filters or something else. As you can see in the file manager, we can upload stuff, filter for different kind of things. And there's an interesting feature which is about changing the interface language. So, for example, if I set that to Swedish and I press OK, I will see that the interface gets translated. But one interesting thing is looking about how the translation works. So while we were talking, I had this proxy in the middle between my browser and the server side, and it was recording all the traffic we were sending to the server side. And what I'm going to do here is taking the very message that has been sent for the change language feature and try to see how it works. Basically, that's what we do. We look at everything that is there and see if something doesn't work. If you're a developer and you say to me, yeah, I want you to put an integer there, I will put an emoticon there probably. So exactly. Something bad is going to happen, maybe, maybe not. And here we can see that if I add some stuff after the language, I get a warning, could not find the language. I have an information about where on the server this stuff is and which script had problems. Actually, I already knew that, but now I have the full path on the file server of the server. Yeah, but this is still boring. So what's the difference? When I send a valid value like this one, or I don't know, NUS, or it's just N, go. Okay, let's stick to Swedish now. If I send a valid value, I get this, and if I send an invalid value, I get an error. What I'm thinking here is that maybe this is a file. Well, actually, I know this is a file. It was in the error. So let me try to load the file. What I'm suspecting here is that there's a path somewhere, and the application is concatenating the value we send here with a path. So let me put // so we are going to stay in the same directory, and it's working. So what we are going to do now is try to explore if we can do something else, if we can get any kind of resource load from the server. Here we have this jobs.php. We know it's a page that is valid, so we're going to try to explore that. One valid idea is that probably this is a PHP file. So probably on the file system, the file looks like this with an extension. I'm going to skip the extension and try to load the jobs page. Not found, so it's not in the same directory. Let's move up.
And this is basically what we do. We assume things. We assume that it's a file, and then we try to verify that by adding paths or whatever that we can move on with, get a bigger picture of how this is built and how we can break it, basically. So we need to probe it. We need to check for everything. We don't just go to this and just click a button and we execute code on the server. Usually we have to spend a lot of time on stuff like this to find where are the cracks and how can we chain these cracks together and how can we exploit this to reach our end goal, which in this case is to execute code, arbitrary code on a system inside the perimeter.
Yeah, and that's all comes from experience. We have experience about developing things, about hacking into things, and we are never going to stop or anything. It's a mixture of approach and experience. You need a person that is with the right approach and the right amount of experience. We are continuing with our exploration here, and when I go 3 levels up, I get one OK. If I send a request again, I get some HTML back. Let's take a look at the response and see what's happening there.
So those backslashes that you see there in the chosen language, the backslashes and the dots, is basically telling I want to move up 1 level in the file system. And every time you enter ... and then a slash, then you move up 1 level, and then you move up 1 level. And then we try to find files outside of this directory that we can check further.
And if you look at this page, which is very ugly but gives us very precious information, we know that we are running the same script about the change language feature we've seen before. But here we are seeing current vacancies. This is a text coming from the jobs page. So we have been able to tell the server, please do run this script instead of whatever you wanted to do. Now, the idea is, how can I run my malicious PHP info page? Malicious. Well, it's quite blunt, but it's going to get interesting later. So we know that jobs and avatars are in the document root, so we're going to run the avatars PHP info file and see what happens. I'm going to send a request. As you can see, it changed. One interesting thing in this kind of bug, you will see me sending requests a couple of times, quite often. It's because how the bugs works. So sometimes these kind of things are quite sneaky. Like if you send something, you send a probe, and you get a response back. It's not related to the probe. You send it. In this case, you had to send it again. Usually, a scanner cannot do that, for example, because they send a request, compare the response, and try to get an idea about what's happening. Here, it's just testing and thinking, yeah, maybe it's working like that, or maybe there's something that I can feel. It's quite odd. Let's take a look at the response again. Oh. As you can see, we are still on the change language, but in this case, we run our PHP info function, so we are getting information about how the server is installed, how it's working, and so on. OK, interesting.
So basically, this is our PHP code that we uploaded through the profile picture function. We pointed another function to that file that executed that code and then gave us back the results in the browser.
And now what I want to do is write a small web shell to being able to send commands to the server. So the server is going to execute them in the context of the web server process.
So a web shell is basically, in this case, a PHP file. Like the PHP info file, we're going to put it on the server, and when we call it, we're going to add a parameter that's going to be the command that we want it to execute. So basically, we're going to send an HTTP request to our web shell that we uploaded. It's going to receive that request. It's going to take the parameter, which is the command that we want to execute on the server. It's going to execute that command, and then it's going to return the command output to us. And that's basically a web shell.
Yeah, and as you can see here, I'm going to send this to the repeater. Maybe I'm going to use it again. Basically, we're using, oh, there's an error. Smart, I did this. We're using a post variable to send our command. This is to evade simple detection. For example, the web server logs all the get parameters, but they don't log the post request by default. So we're going to send those and see what happens in our backend. So now I have this code on the server, and I'm going to include it. So I'm going to add the CMD here and see what happens. Here it is. We are listing the directories.
Is the actual command that's getting executed on the server.
Right now, we are running any command that we want from that CMD parameter in the web server, in the machine itself, like we were on the console. And that, what we can do really depends on the user on the web server. That's www data. It's a default Apache user on most Linux distributions. But let's dig around and see and get some more information, basically. First of all, I'm going to see where we are on the server. Then we can take a look at the document root. Here we see, for example, our avatars. Sorry. And we see that we can write there because www data is in a, that directory is on the by root, but is in the group www data. And there we can write. No surprise, that's the place where we were uploading stuff. So let's try to see and understand why we weren't able to run code there. We have this small file here, and that's probably, please note that that file is not writable by us, so we cannot edit it. And now we're going to see what's there. OK, PHP flag engine off. This means that we cannot run code there. We cannot edit that file to change that. The server has been hardened. If we take a look at, I'm going to now try to find in the web server root all the places where I can write, because our idea is, OK, now we are there, we are running commands, but we want to get back and possibly not tie this to a session. So we want to try to hide as much as possible. So let me see. I'm going to find in the document, in the web server root, all the stuff that is writable by the group or other users. And here we find the avatars. We already know that. Oh, please note that this is going to be returned double. This depends on the web application, not on us. And we see where we were uploading things. We see that there's a thumbs directory in the file manager, and there's a small directory here. I'm going to ahead and tell you that if we're going to explore these guys, they did the same harden that they did on the other part. So we cannot run code that we upload there. So even if I upload some malicious code or I write it directly with my command, we will not be able to have some PHP code running there. What we need in this situation is see if we can run it in this place. So no apparent hardening, nothing particular. What we want to do here is getting persistence. We can upload a shell like the one we just used, and then get back to the server whenever we want. We don't need to log in again with our account, leaving traces. We can just upload the stuff, maybe delete the account, and continue with our lives. But we know that we have access to the machine whenever we want. In the actual engagement that we used for getting inspiration for this talk, the server was very well maintained and very well hardened. So we didn't manage to find another way in. Getting back to our map, we can run code here, but we are the web server. We don't have a lot of rights. We can read the database of their users, all the stuff which is on the web server. We can influence some of the parts of the website, but we cannot proceed more. So it's more like we're kind of in on that exposed server part. So it's time for us to do something else. We know we can write code that we control somewhere on the web server. So we can exploit this and target the users, but it's going to be way easier for us because we are going to send like a link in an email, and the link is pointing to their own corporate website. Why shouldn't I trust my own website? I know I'm in the company, I have an IT team working on that, so I'm going to trust it. Also, we can try to target the Leon Vargo guy who's going to get all the CVs. He's probably going getting emails every day and is not going to think about it. So let's see how we can do that. Basically, here I have an already prepared script where, well, let me show it before. Our script has some content which we're going to discuss later. I know it's not very clear. And it's very simple. We have a header telling to the web server, this is a zip file, and we are forcing it to serve it as an attachment, so the user are going to download it. And basically, we are sending, OK, present the user with a file download window, and provide this code. The code is the content that we have seen above. So let me upload it, scripts. OK, now our malicious script is in the avatars directory where we cannot write stuff. So I'm going to just copy it in the position where we are able to write things. And we need the file name. And go. Done. And the cool thing is that it's named PDF download for a reason. It's very common for most services to have a kind of proxy for downloading files. So what we can do here is like, well, I was Dade Murphy.pdf. I'm sending a link, an HTTPS link on my own, on their own corporate website. It seems to be a file, a PDF file. When I download it, it's a zip file, and we're going to see soon what's happening when you download that file. But it's we try to be as sneaky as possible. And when our Leon Vargo is going to check his email, he's going to get a link with our PDF file. And he's going to click on that link. See the running security scan here.
We already heard Marcus talking about the statistics and how easy it is to get someone to execute code that you send to them, if you craft it correctly.
You know what? If you take the screen, I'm going to switch to another network.
Yeah, I think I think the internet went down.
Yeah. Well, you can do an introduction, I think, and then.
Yeah. So while David is fixing his internet, we've been talking about how to breach the perimeter. We saw our demo example, which is basically one of the routes that we chose to show you. We're going to receive a shell hopefully soon, and I'm going to show you. We're going to talk about a specific technique. We're going to go to talk about domain fronting after this. But did you get internet working?
Yeah, it seems like so.
Okay, so
I'm just going to double click. I got a warning, but yeah, it's from my own website. We have people doing way worse, so run. And after a flashy, of course, in a real engagement, we are not going to use this. Yet, I think it's time for you to enter the game.
okay. Empire. So let's just pray that we get our connection. We already seen PowerShell Empire. Marcus talked about it. It's been used in the big case in Malmö right now. It's an open source post-exploitation framework. It's basically a framework for hacking with a bunch of different modules. It's pretty much focused on PowerShell, but it also have Python capabilities, and so it can exploit the Linux servers or Mac endpoints as well. We're still waiting for the shell to drop in, so see if the demo goes through Lazarus or not.
Yeah, I think when I download it, probably the machine didn't get the connection yet. Let me see.
We'll try again. So we're going to just show a little bit about Empire if we get the shell working, just to show you how it looks. We don't use it that much. It's out there. You can download it. It's open source. You can look at it. We know that the threat actors are using it. We know that it's been used in Sweden, like we said. And let's switch over to our next subject. Oh, there we go.
Yay!
So here we can see that we launched an agent on the victim machine that we compromised. That agent is going to talk out of the network so that we have a way to execute commands inside the network, basically. So we talked about the web shell earlier. That this is a more advanced shell where you can upload PowerShell, you can download files, and you got all this fancy stuff. So if we go into agents, we see that we have that one. We can interact with that agent. And from here, we can execute commands. So now I'm talking to the agent. What's happening here is that the agent is polling. So it's talking out. It's polling our command and control server, asking, is there something for me to do? Is there a command that you want me to execute? And I don't know how to zoom in. I'm a hacker. Marcus got all this fancy stuff where he zooms in, paints on the screen and all that stuff. There you go.
I have shortcuts.
Yeah, I get the
Plenty of
Italian
them.
guys, they know this stuff. So from here we can execute commands as we've seen through the web shell. It can be a bit slow, and that's because we have to wait for the agent to pull back asking, do you have something for me to do? Yes, run this command, and it runs the command, and it outputs the output back to the command and control server. So we can execute commands on the server. We also have a bunch of modules in PowerShell Empire. You can write your own modules, or you can use a bunch of modules that's already in there. A module is basically just a package of code that you want to do something on the server, and you want the result back. So we have, for example, situational awareness. And inside here, we have host and network. So if you check host, which doesn't have as much as network, we can see that we have some stuff we can run here. We can see if it's, the host is using a system proxy. We can check the antivirus product, for example. So if we use this module, we type info. All the modules have different parameters that you can set depending on what the module is supposed to do, if you have to enter credentials or paths or whatever. Right here, we don't have too much. We have the agent that we want to execute the module on.
And it's very important to explore where you are. Like at the beginning, we explore the website or gain other information. Knowledge is power, and it's power even when you're doing malicious stuff. The more you know about your target and where you are, the easier and more sneaky your attack is going to be.
Exactly. So just like we said before, we're in the beginning of an engagement, you start to ask yourself questions. What are the target organization exposing? What do we have to look at? You restart that thinking once you get inside the network. So we're in a different situation now. We're inside the network. What do we have here? What kind of servers can we reach? What kind of privileges do we have on the system, and how is the system configured? So this doesn't seem to do anything. That's alarming.
Did I get my connection down
There
again?
you go. Job started. So it could be a bit slow. We're using mobile hotspot right now. And here we get the results back. So we can see that it's using Windows Defender. We get the computer name and some information about that. And this is just one of a lot of modules in PowerShell Empire. So this is how you can use Empire. And you can pretty fast realize that you don't have to be a computer genius to be inside of this interface. You just have to know the basic, basically. You're probably going to get caught, but you can do a lot of damage from just downloading open source tools, going through a few tutorials, and then you just go nuts. And that's basically what they did.
And one interesting thing is that now it's actually cool that we are going through my phone, because usually the mobile broadband is heavy filtered, not like a company, but it's filtered. So the cool thing is how we are doing this stuff, because we are going through a lot of systems that are preventing us from doing some things. They are not allowing traffic on strange ports. They are not allowing some kind of traffic. Still, we are getting all the information that we want, and we are running things on the machine. That is something to think about, in my opinion.
Yes, and I want to talk about something that we haven't mentioned. We're going to talk about domain fronting. It's a specific technique. So far, we talked more about the concepts, about breaking the perimeter, and we're going to talk about domain fronting. It's a specific technique. This shell that we are looking at right now is using domain fronting. I'm going to switch over to some slides to try and explain that.
In the meantime, I will put my laptop here, because I want to get a good view of you guys. Let me see.
OK, so domain fronting.
Something like that.
On a very high level, what you're trying to do is you're trying to hide the malicious endpoint that you're talking to, if you're talking to a malicious endpoint. These kind of techniques are also used a lot in privacy, trying to circumvent censorship, and we will go into that. But what you need to the only thing you need to know right now is basically you talk to an endpoint. You don't want whoever is monitoring that network, the organization or the country, if it's censorship, you don't want them to know who you're talking to. So what you do is you use a high reputation domain, such as Amazon.com, Google.com, Azure. There's a bunch of them. And what the company see, or what the censor sees, is you doing a regular HTTP connection over TLS. It's going to be encrypted to Google.com, for example. But inside that encrypted package, you tell the server receiving that request at Google to instead go to this guy instead. Go to this malicious site instead. And that's a parameter that you can't see inside the encrypted package if you don't decrypt the package. If you don't do TLS inspection, you're not going to see that host header inside. And I'm going to go through the technical part. This is more a high-level one. One way to do this is to go through content delivery networks. So what a content delivery network is basically they try to speed up things. If you're in China, you have an edge server in China that you talk to make the connection fast enough, and then inside that content delivery network, they route the traffic to the correct servers and whatnot. So what you can see here is that from the victim, where we execute code, you initialize a TLS encrypted connection to the CloudFront edge server. And the only thing that the organization, if you have a firewall in between the victim and the cloud edge server, the only thing that you're going to see is our high reputation domain. And it's going to be something like google.com or whatever that you don't want to block. And then when that cloud server receives that request, it unpacks the encryption, and it looks inside for a host header. And that host header is going to point to our malicious server inside the CloudFront CDN network. And then it's going to route internally, and the organization or the sensor or whoever is watching that traffic is going to think that it's regular traffic to google.com, for example.
Yeah, and it's, again, a very highly reputed site, like, I don't know, Instagram, Twitter, Facebook, you name it. Every major web application that you find on the internet is using a content delivery network. And many of them are using providers that also provide any kind of service for private individuals.
Exactly. And so I'm going to try to present this as a story slash timeline. In July 2015, a guy named David Fifield had a presentation on pets. It was very privacy-focused. It wasn't hacker-focused. It wasn't how bad guys use domain fronting to circumvent security measures in different organizations. Instead, they focused on blocking resistant communication through domain fronting, where the blocking part is a sensor. So in a lot of countries, they try to block different services. They try to limit what the residents of the country can browse on the internet, basically. And it didn't get too much attention. It did get some attention. However, after that, in December 2016, there was a Signal update. Signal is kind of like WhatsApp. It's a messaging application where you can do text calls, voice calls, or instant messaging, and it's encrypted end-to-end. So it's both a protocol. You have the Signal protocol, which the Signal application is built upon. So the Signal protocol is open source. It's cryptographers seem to drool over it. It's often referred to as the gold standard for end-to-end encryption in messaging apps. And most notably, it's inside WhatsApp. WhatsApp is built on top of the Signal protocol. And what happened here is that Open Whisper Systems, which is the organization developing Signal, got user reports that Signal isn't working in Egypt and in United Arab Emirates. So they started to investigate this with the help of users from those countries. And what they realized is that a lot of ISPs, internet service providers like Bredbandsbolaget, Bahnhof, or whatever ISP you use, started blocking the Signal service and the Signal website. So what they did then is implement domain fronting. So if you're inside, if you have the Signal application installed and you have a country code from Egypt or United Arab Emirates, the domain fronting feature is going to switch on automatically. So what happens is that it started working again. All the traffic looks like it's going regular web traffic to google.com, and everybody could use Signal again. So what happens here is you try to use, like, you don't want to block google.com probably. And if they do, let's switch over to amazon.com. And pretty soon, it's going to start to look like you're blocking the entire internet. So it's hard to block everything that we can use domain fronting from these days, because we have these big CDN networks, and we have these services that works in this way. And with that update, they get a lot more, the technique got a lot more attention. So there were early 2017, we saw a lot of implementations. We saw a lot of tutorials on how to do this. It got implemented in PowerShell Empire, which we have been talking about a few times already. Got implemented in Cobalt Strike, and you got tutorials how to do it in Cobalt Strike, which is more of a collaborative tool for red teamers and hackers to collaborate on their hacking efforts. And it's also getting implemented as we speak in Metasploit, which is probably still the biggest hacking framework out there. So, it's interesting that it's an old topic. It's from 2015, but it didn't get the attention that it deserved. And then something that media picks up on or people think is cool, like the signal update, where you circumvent censorship in domain fronting. All of a sudden, it's this cool technique that you can use. And in March 27, FireEye Mandiant released a report on APT29, also known as Cozy Bear, the Russian state-sponsored hacker group. And what they noted in there is that, yeah, they use domain fronting. It's popular to talk about in March 2017 anyway, so we already know about it. But the more interesting part of the report is that they make the notion that they've been using it for at least 2 years. So we know that bad guys have been using it for at least 2 years, but a lot of organizations started to look at it and got the information about that domain fronting even existed a lot later than that. And of course, that people that love privacy and information security and all they do is read blogs about it, they probably knew about it before. But we know that a lot of organizations did not know about it. We know that a lot of organizations still don't know about it. And we know that a lot of organizations don't do anything about it. So they don't block it, don't monitor it. It's just there that the attackers can use it. And we know that they are using it. And so that's an interesting perspective, if you ask me, that we have all these techniques, and they're just getting more and more all the time. We can't block everything. We can't know about everything. So how do we stop these guys? So if we look in the APT29 report, for example, they do a lot of other stuff as well. They don't just do domain fronting and nothing else inside your systems. So what we have to focus on is the stuff that we do know. So we know that they use the sticky keys exploit. It's an exploit where when you get to the login screen of the RDP session, or when you log into your computer, you press Shift key 5 times because you're mad your password don't work. And then you get this pop-up saying, do you want to activate sticky keys? And that's an executable on the system. It's an exe file. If you switch out that exe file for a cmd.exe file, a command line, when you press Shift 5 times, what's going to open? It's going to open a shell. You're going to have a terminal. And that terminal is going to have system-level privileges. You don't even have to have any credentials. You don't have to do anything. You just have to be at the front, at the screen where you enter the credentials. So what APT29 did is that they used a publicly available Tor plugin. That Tor is the onion router. Probably most of you have heard of it. It's a way to try to be anonymous online. It routes traffic in an onion fashion where it peel off layers, so only the last step and the next step is known to the current step. So nobody knows the entire chain, basically. So what they did is they used the Meek plugin to forward traffic from their victim host, turn that traffic into HTTP traffic that looked like it was talking to google.com, regular web traffic, on Google app. They hosted their malicious reflector server in the Google Cloud. So what they did is they received their reflector server received those domain-fronted requests, and then it repackaged those requests into Tor network traffic and put it out on the Tor network over to APT29 to control their server. So what they did is remote desktop through domain fronting through Tor into the systems, and then they use other exploits from there. So obviously, we need to monitor. We have to know what's going on inside our environments. We don't want the sticky keys executable to be switched out for a command line, cmd.exe. Other stuff that they did is the usual stuff that hackers do. They installed a Windows service called Google Update to keep persistence during reboots. They enabled multiple concurrent sessions for the same account, so they could RDP in with the same account that somebody else was already using. And that's a registry key value. We have to know those stuff, because we don't know everything. Some people might, but if you look at the average organization, they don't know everything, and they don't have blockers for everything. So we need to look at what we do have and what we do know, and we need to find the attackers right there, because then it doesn't really matter if they do domain fronting if we find them on the endpoints anyway.
The point is that attackers do not stop. They're very, very persistent at what they want to do. In our short demo today, we tried to get into a server. We found a vulnerability there. It wasn't something big. Then we found another one. It wasn't something big. Still, we chained them together, and we got to code execution on the server. We found a way to get persistent to proceed because our server was isolated, and there was no other way to the internal systems, which are our next target. So we switched that to social engineering, exploiting the fact that we already compromised something. So we chained those things together. And when we got into our internal system, even if we are using some, in this case, a tool coming from the internet, we try to configure it in the most stealthy way as possible. And that's something that is a very important lesson. So attackers do not stop. If they find a path that doesn't provide them too much resistance, they are going to continue on that. Like a child that wants to go to the park, they are going to ask the dad and the mom, then try to say, yeah, but the mom say yes to the dad, and so on. Being committed to the goal is very important. And basically, what they're doing, the criminals are balancing. It's a business. So you're balancing how much you can gain and what's the effort you're going to put that into. If you have multiple ways at your disposal and you find a way to get like a manageable effort to gain a lot of money, then why you shouldn't do that from a criminal perspective? And we've seen also that since you're not going to the place you're attacking, we can hide ourselves through the network. So the chances of being caught are lower than the usual crime where you go with a pistol and rob someone. And I think we can maybe close with, now we have a stable connection. We should show
Yeah, I
something
just
cool.
wanted to show really quickly, because I want to do something on the computer, how domain fronting works how to visualize it, basically. So if we have this website, this is...
Let me zoom in.
Boom. We have this website. It's just a website on the CloudFront CDN. Oh, my bad. If we do a DNS query, we ask where does this point? We can see it's clearly on CloudFront. So, skip that part. But so here we have a curl command. This is basically just the same thing that you do when you open a browser. It asks what is at this endpoint. So if we do this, we're going to get a lot of HTML back, which is basically rendered in the browser. So this ausregistry.com.au is what the organization can see. It's what's going to be in the domain name query, and it's going to be the one server, the server SNI, server name indication during the TLS handshake, and that's what the organization is going to see. But inside that encrypted package, we can put this host header, which points to another host. So this is our malicious host in CloudFront. And what we get back then is the response from the malicious server instead of what the organization is going to see, the osregistry.com.au.
And this is the actual machine we are using. We created a machine on the cloud, and we are using that for this very demo. So
Exactly.
It's not incredibly expensive, and it's manageable. And again, there are tutorials on the internet. If you want to gain to a really stealthy level, then you need to custom code some stuff and do other things. But we see that there are a lot of people that is successful just by using tutorials of the net.
Yes. So we're gonna finish with some fancy module. Of course, there's a webcam recorder in there. So if you check the info, you can see you get record time. Let's
run it like that.
Okay. You can set the amount of seconds that it's going to record, basically. So let's try this.
I hope I'm going to take the audience. Please, someone in the first row, take a look at the LED on the top of my screen so you see we are not cheating. And someone do something. I don't know. Think Italian. Do something. So we are sure that we are going to get something
So
new.
as you can see, it even tells you that it's not OPSEC safe. So
Let me see.
we're going to have to wait until it picks up the job, hopefully before lunch.
It's recording. So do something, please. Yeah.
Move around.
All of you wave. Thank you.
We have to make sure we're not faking it.
It finished.
Okay, so
Now that our victim is uploading the video on our CloudFront machine, and in a while we're going to take it down and take a look at it.
exactly. So hopefully it's going to end up here soon. We have our mobile connection to play with. Come on.
I saw that sometimes you don't get a
Let's check it.
notification, but the file is there. So you can probably take it.
What's the name of it? No,
It's
don't
cool
seem to
because
be
we are
there
doing
yet.
this live, so
Yeah. So let's hope that is coming up.
well, if you want to wrap up a little bit, I can try to
Yeah,
find the stuff.
We'll check it before we end.
But I don't want to use my laptop, otherwise they will think we are cheating. So before I borrow this.
So that's pretty much the first session. We've been talking about breaching the perimeter. We've been talking about how you enumerate your target, how you collect a bunch of data, you turn that into intelligence, and you act on that intelligence. Then you rinse and repeat. You do that until you reach your end goal, basically. And the end goal may vary depending on what organization you are trying to breach. And
I think we are not going to get it.
okay, so the demo ghost didn't let us, but you can just assume that it worked, obviously. So that's pretty much it from us.
That's the point. If we take, can you take out the graph? If you take the initial graph we have been seeing, now we are halfway here. We got in a machine on the internal network. We are a normal user at this very moment. And our goal now is to escalate that and expand our control over other systems. And then go through all the possible path that we can find to reach a high valuable target. And that's our goal. That's it.
Hi.